This is Chapter 6, Section 3. This is solving systems using elimination. So this is just another way of solving a system of equations. Before it was graphing, and now we're moving on to adding or subtracting to eliminate variables and then solve the system. So what we want you to recall is this kind of stuff. You don't necessarily have to write it down, but you should keep it in mind. Your properties of equality. So if A equals B and C equals D, then if you take A plus C and B plus D, and A minus C equal to B minus D, these things are equal to each other. So what we're saying here is if A and B are the same, right, A and B would be the same, and C and D are the same, adding them up should give you the same answer, right? Or subtracting them should give you the same answer. And here's a pretty good way of showing that. If 5 plus 1 equals 6 and 3 plus 4 equals 7, 5 plus 1 plus 3 plus 4 should be the same as replacing 5 plus 1 with 6 and 3 plus 4 with 7. It should give you the same answer. Okay? So here's how we do this. We use something that's called elimination. Okay, and when elimination is getting rid of one of the variables so that we only have one left. Okay? Now, in the setup of this one, that's very easy. If we just add these vertically. Okay, so what is 2x plus 6x? That's 8x. What is plus 5y minus 5y? That's 0y. So those cancel each other. 17 minus 9 is 8. And now we solve for x. Divide by 8. And you get x equals 1. So now we have an x value. And if we take that x value and plug it back into either one of the equations, plus 5y equals 17. This is 2. Subtract 2. We are left with 5y equals 15. Divide by 5. And you get y equals 3. So now what is the solution? The solution is 1, which is our x, comma, 3. And that is solving a system using elimination. Okay, let's give you another one. So what we're looking for is things that are basically inverses of each other. Negative 6y and positive 6y, or negative 3x and positive 3x. When we have those, it's fairly simple. Okay, so I'm not going to worry about B. I'm going to do A for you right now. Well, how about this? We'll do this one instead, since we've already eliminated y's. Okay, we'll eliminate x's. So negative 3x and positive 3x, those, remember we're adding them, become 0x. So they eliminate each other. Negative 3y minus 4y is negative 7y. And 9 plus 5 is 14. Okay. Divide by negative 7. And y becomes negative 2. Now take negative 2 and plug it back into either one of these. Kind of like this bottom one a little better because it's one less negative I have to deal with. So I take 3x minus 4 times negative 2 equals 5. 3x negative 2 times negative 4 times negative 2 is positive 8. Not sure what I'm getting. 15. Subtract 8. Those cancel, and we get 3x equals negative 3. Divide by 3, and you get x equals negative 1. So therefore our solution is negative 1, negative 2. And we can check this by plugging it back in. If we take either one of our equations, again, let's take this one and plug them in. 3 times negative 1. Where'd my pen go? minus 4 times negative 2 equals 5. 3 times negative 1 is negative 3. Negative 4 times negative 2 is positive 8. Negative 3 plus 8 is 5 equals 5. So that shows us that it works. We are correct. So this is our solution. That is where those two equations, if you graphed them, where they would intersect. It intersects somewhere down here at negative 1, negative 2. Okay? All right. Top over those two. So what happens if our x and our y's aren't the same, if they're not inverses of each other? Then sometimes what we have to do is multiply one of them or both of them by something. So what could we do in order to get either the 5 to become 15 or the 2 and 7 to match up? Now, here's the easiest way, is to get negative 5 up to negative 15, I could multiply the whole thing times 3. And that would give us 21x minus 15y equals 51. And then if I bring this equation down, negative 2x plus 15y equals negative 32. Those cancel, and I am left with 21x minus 2x, which gives us 19x equals, this is 1832.83. Whoa. Sorry. It's 19. Gosh. I was counting the difference between them. And then divide by 19, and you get x equals 1. Now that's the easy way to do it, right? But what if say these numbers didn't match up perfectly? Okay, then you would plug x back in and you'd get your y. What if these numbers didn't match up perfectly? Let me show you what you would do if, say, both our x's and our y's were something like 2 and 7. What we'd have to do is we'd multiply the top. I would multiply it by 7 and the bottom by 2. So that way, 2 times negative 2 and 2 times 7 are going to give us inverses of each other. So this becomes negative 14x. This becomes 105y. And this becomes 210 negative 234. This becomes 14y, negative 10y, and this becomes 34. Okay? These cancel. We are left with 95y equals negative 200. Sorry, I figured out where I messed up. 2 times negative 32 is not negative 234, it's 224, which means that this becomes negative 190. Divide by 95, and y equals negative 2. And now you can plug in negative 2 back up here. Negative 2 times, negative 2x plus 15 times negative 2 equals negative 32. Negative 2x minus 30 equals negative 32. We add 30 to both sides. We get negative 2x equals negative 2. Divide by negative 2 and x becomes 1. And therefore your solution is 1, negative 2. Which comes out to be the same as if you would have done it the other way. So what I'm trying to say is there's multiple ways of doing this. Sometimes you have to multiply more than just one equation. Sometimes you have to multiply both of them in order to get them to eliminate. So it's just kind of you know, try different things, see what works. But if you ever have to do that, you're just, whatever this bottom number, this number is, that's what you're multiplying your top equation by, and whatever this number is, that's what you're multiplying that one, so that you get one negative and one positive with the same number, and then you can eliminate them. So that's the gist of solving a system using elimination.